Welcome everybody to another episode of vBrownBag. This is part 2 of VMware Validated Designs with Ryan Johnson at 10:30 a.m. on Twitter and Nick Marshall at NickMarshall9 on Twitter. Some quick notes. If you want to get in on the conversation, you can write to us, especially using the hashtag vBrownBag. We are monitoring that during that conversation, during the presentation. And don't forget that we have several vBrownBag paths, if you call them. They're regional. We have APAC, EMEA, Latin America, and US. If you have any questions for our presenters, you can also reach directly to them out in Twitter. And if I can help you anyway, I'm your host, Kyle Ariel. No, it's Ariel Sanchez. And I'll now let Ryan and Nick introduce themselves, and while I pass control.
Let's go ahead and pass that control over if you don't mind. And share my desktop.
There you go.
All right. Let's see if I can see things on my minimize a bunch of things. All right. All right, guys, we're going to talk about the VMware Validated Designs. This is kind of part 1 of maybe 2 or 3. We'll see how far we get today, but probably we'll get through 2 of 3 because it is a kind of a deep level topic, the VMware Validated Designs. And specifically, we're talking about the VMware Validated Designs for software-defined data center. And last week, we kind of went over the why, and the how we build these the VVDs, as we call them for short. And we left off, basically, we're going to start talking about the physical infrastructure layer of the VVD for SDDC. We're going to talk about specifically version 3.0.2. We did mention that there is a new version coming out pretty soon, and you can get early access material to that 4.0 release on the VVD community at vmware.com/go/VVD-community. But we're specifically going to be talking about the version 3.0.2 of the design. And just so a quick introduction for myself, Ryan Johnson. I'm a staff tech marketing architect in our integrated systems business unit at VMware, which is basically a fancy way of saying that I focus on pretty much all things SDDC. So all the different, how you take all the different components of the software-defined data center, from vSphere, vSAN, NSX to VROps, Log Insight, VRA, and other components, and put them together into an integrated stack. And we do that specifically in 2 different ways in my business unit. One's the VMware Validated Designs, and the other one is probably you've probably heard about VMware Cloud Foundation. You can follow me on Twitter. My email address, you can want to email me directly at VMware. By all means, feel free to do so. We're also joined by Nick. I think Nick's back. Nick, you back?
I'm here. Hey everyone. Yeah. Happy to do so. Nick Marshall. I work in the ISPU alongside Ryan. I'm in the Sweep Design and Test team. So while Ryan is more external focused, I'm more internal focused, but we both work on the same stuff. So I look after architecture for the VVDs, along with, I don't know, half a dozen other guys, and looking after Cloud Foundation architecture soon as well. So there's going to be some merging of the thoughts there, but that's a future thing that will hopefully get done sooner rather than later.
Excellent. Yeah, and Ariel, if you guys want us to come in and do some deep dives and demos on VCF, we can do that as well. But today we're going to be talking about the VVDs. And so like I mentioned on the last one, hopefully everybody who did get a chance to attend last one, listen in, we did mention that there is a poster, right? We talked about some high-level pieces, the who, the what, the why, the how we do the VVDs. Today we're going to kind of start digging in a little bit on the actual design, right? And a good primer for this, I think Nick would agree, is just technical poster that we put together. It basically goes over some of the core pieces we'll talk about tonight, core platform, NSX, Hopefully we'll get to view our ops and login site and things like this, those pieces. The way our network is set up, the way we do distributed logical routing, all this is depicted, the high-level points are depicted in a poster that you can go download today. If you go to vmware.com/go/vvd-stdc-poster, it will redirect you to our community, and in the community we've posted that poster. You can download it in digital format, zoom in. If you want to take it to your neighborhood FedEx Kinkos, I'm sure they would be happy to print it off for you. We don't have any printed versions just yet. So do make sure you go out and and review that, download that. It will help to simplify an understanding of the key architectural elements of the VVD, but it is not a substitute for reading the documentation itself, which is very prolific and very detailed. So tonight we're going to talk about the physical infrastructure pieces, like the physical infrastructure layer of the design, what we need and what some requirements are, and be able to dig into some of the virtualization layer, and see how far we get, just to kind of get you guys up to speed. And from that, we're going to start with the physical layer. Okay. So, and Nick, Nick is your show too, so chime in anytime. So one of the things that when we started to build the VVDs, right, we wanted to build, the best SDDC possible using the software, our own software. But we should say, the SDDC has to run on top of something. It can't just run in the ether. It has to run on top of some physical hardware, right? But we wanted the barrier to entry to be, as low as possible, right, on the environment and external systems. So as we're reading through the documentation for the 3.x design, so let me say the external system requirements are pretty minimal. I mean, obviously, we want to actually have the right environmental systems and external systems. So the environment being like, hey, do I have rack space to put this architecture into place in my data center or my colo, where have you? Do I have the requisite real estate for it? Do I have necessary power and cooling? Right? Can I provide dual power? Can I provide enough cooling to keep the systems cool and keep them with non-operational ratios? And then that's kind of all the basics you would expect, right? And we actually detail a lot of that inside the VPD. Of course, you do need to make sure you take a look at what your manufacturer recommends as far as power and cooling. With regards to external systems, we made that as minimal as possible. We do require Active Directory for the systems. We use that for authentication, authorization. We do give some examples of how to do things like with certificate management as well, using the Microsoft Certificate Authority built into, or provided with Microsoft Windows Server and its array of services. We do provide guidance on using the Certificate Authority. We do obviously require a proper DNS and NTP be established, right? Both forward and reverse DNS, long and short, right? As well as a good operational NTP, because hopefully everyone on the call understands the value of these core resources. I like to think that these are becoming more and more important, right? As we move forward, if you deploy vCenter, if you have one of those as of 6.0 misconfigured, it will come back to bite you. So you do want to make sure you have proper forward, reverse, short, long DNS, as well as operational NTP. SMTP relay, we want to make sure we have an SMTP relay so we can obviously send messages to operators, send alerts, whether it's something from vRealize Login side or vRealize Operations, or even something from vCenter itself or other systems. We'll make sure that that's running. And then we have the requirement down there for FTP or SFTP. I like to lean toward the secure file transport, right? And we use that today primarily for NSX, backups for NSX. Do we use it for anything else right now, Nick, besides NSX backups? I think that's the only piece that we use it for. Yeah. So those are the basic environmental system requirements.
We got
Sorry,
one question.
I was talking on. Sorry. No, we don't.
Go ahead.
Push to talk does not work on GoToMeeting. Just a hot tip for everyone out there. Push to talk only works on Skype.
Good. So there was a question.
Yeah, there was a question about should should people think about putting all the VMware stuff in a subdomain, for example? What is there any guidance on that? Is there any size of an organization where you say you probably want to keep this thing in your subdomain, for example?
So that's an interesting question, and I'm sure Nick can dive down a little bit deeper. Like, so, you could do this in your root of your domain, if you will, right? If you wanted to put this in, let's just call it VMware.com for, lack of a better word, or rainpoll.local, as we usually see in our documentation. While you could put it in the root of your domain, you will see in our documentation we do provide like subdomain infrastructure. You'll see that it's really based on sites, so you will see us like have subdomains for like SFO01, right? And that's for San Francisco, the first site in San Francisco, or LAX, Los Angeles. Right? Those are just examples, example guidance. But if you did want to put everything into your own domain, you could do that. But we do provide some good guidance on how to establish it based off kind of a subdomain. So again, like a site locate, a site, three-letter acronym .domain.com for the namespace.
Awesome, thank you.
Can I just add a little bit to that? Can I add a little bit of depth to that? So within the documentation, we've got, as Ryan said, we've got multiple domains in there. We didn't do that for a scalability perspective. I think that Active Directory, DNS, our stuff will scale well beyond the size of what the actual SDDC is scaled to, which is 10,000 VMs. So one of the things that we have run up into in the past is if you've got hundreds of thousands of users and computer accounts within your Active Directory, that's right, hundreds of thousands, then there are certain configurations that you should probably try to adhere to around splitting those domains up, those users and computers into subdomains, just to limit the amount of time that SSO is going to be querying for domain name lookups and user lookups and SAML authentication and all that kind of thing. So there are certain constraints, but if you're one of those customers that have hundreds of thousands of users and computers, you already know about that stuff because it's not a VVD specific thing. It's just a how do we deal with that kind of scale. So most customers don't have to think about this, honestly, but if you're a big customer, you already know that you do because you've already hit it before you've done this. Awesome.
Yeah, the size of your token might get increasingly large as you continue to have this number of relationships between groups and the users. We saw that back in the day with DRA authentication. The token was too big. Cool. One thing we have mentioned before is the VVD does support a dual region deployment. We talked last week about the differences between availability zones and regions. Today we do a single availability zone in the design. Looking forward, in the future, possibly doing like metro multiple availability zones. But today it's a single availability zone with support for dual region. And you'll see in our documentation it's kind of what we call region A, region B in the documentation for the dual region. You will see that we use the construct of like San Francisco for region A, represents region A, and region B represents Los Angeles. Now that could be whatever you want it to be. It could be Orlando and Atlanta. It could be Melbourne and Sydney, right, or what have you. Los Angeles and New York, right? There's a couple different ways to approach it, right? Essentially, the characteristics are, it's regional distance. And we treat the entire those two regions as a single SDDC. There's different ways you can kind of split that up, but the whole point is to make sure the workloads are as close to the end user as possible. So some ideas, Northern, Southern California, East and West Coast, U.S. You have a U.S. region, you have an EU region. Just got to figure out exactly what how you want to design that. The whole point is, some uses we have there are providing disaster recovery, right? So, they both are going to be active regions, right? They're both going to be running active workloads. But you do have the ability, so you can fail between regions. So I could fail, I could have workloads running in San Francisco and Los Angeles, but if a disaster happened, I have the ability to move workloads. San Francisco gets a bad earthquake, both of them. We could possibly do that, but I have the ability to move workloads, cover workloads over into the secondary location. And one of the cool pieces is we also have the ability to, in the VBD, is to actually move the management stack, which we'll talk about. So the components like VROps, VROps, VRA, Zero's Business for Cloud, and those components. We have the ability to actually fail those over and recover those in a secondary region using a combination of NSX, vSphere replication, as well as vSAN. So we do support dual region, single availability zones in the design. We mentioned this a little bit last week, this construct of pods. Let's see if this builds out here. So we use this construct of pods, and pods are essentially standardized building blocks, standardized elevations and building blocks for the SDDC in the VBDs. We standardize specific elevations. It's all based on I sometimes say is what's old is new again, but it's also connected to a layer 3 leaf and spine network. We do, make sure we have good out-of-bound management for our kit. But the nice part with these pods, although we standardize elevation, we've got layer 3 leaf and spine, right? We've got out-of-bound management networks set up, but we want to give them specific functional roles in the SDDC. What's their role in life? So we define exactly what the use is going to be, right? Is it going to be used for management? Is it going to be used for edge? Is it going to be used for compute? Is it going to be a combination therein? And that, it makes it easy to deploy, right? We have kind of a standard deployment model. We always deploy for the management stack or the edge stack and guidance for how to do it for your compute. You'll see that in the slides to come. What it kind of looks like in the VBD, we'll call it a two-pod design. If you look at our design objectives, it's called a two-pod design. So as you're staring at the screen here, just imagine that one on the right side doesn't exist right now, but we have this concept of the management pod, and the management pod is where we deploy and instantiate the SDDC. Right? Think of this as a management cluster. VMware's been talking about doing management clusters for quite a long time now, at least as far as almost as long as I've been using the products, and mine goes back to 2005 using it, not as long as others. But the concept of using a management cluster, right? And the management cluster is where I'm going to put the key pieces. I'm going to put my vCenters, my PSCs, my NSX managers, all my VRA, log insight, all the pieces that are going to instantiate and operate the SDDC. Now, mind you, you can put other resources in there for management stack, but we're very prescriptive on this management stack. I will mention that today, you'll notice down there it says virtual SAN and NFS. We'll get into this a little more, but we are using vSAN ready nodes, for the management pod. We do prescribe that, unless that's changed, Nick. We do prescribe that. It starts with four hosts. Today, 128 gigs minimum for memory. We'll dig into those a little bit more, but they are vSAN ready nodes. And the nice part is they're qualified configurations, certified configurations from our vendors, with the right recipes for the drives, the model, the BIOS, the controllers, etc. But we use in vSAN for the data store, the primary storage for the management pod. Now, in the middle here, you'll see what we call the shared edge and compute pod. This was actually an introduction, I believe we did in our 3.0 release. I believe it was a 3.0 release. Yeah. We went from having this 3-pod architecture to what we call a 2-pod architecture. This was just simply, we heard back from our field, we heard back from our customers, our community, partners that, the design in 2.0 is great with a 3-pod, management, edge, and compute being separated, but customers wanted a smaller footprint to get started. When you had to have 12 nodes for a single region to get started, 24 to get started for a dual region, it became a little expensive. We were prescribing vSAN ready nodes for edge. And so we started looking at the design, and we modified it to say, you know what we'll do is combine the edge and compute into an initial shared edge and compute pod. And that way we can prescribe some resource pools for the edge services that we need. This will provide the ingress and egress for the software-defined data center, for the workloads running in the software-defined data center, for the tenants or the business units or whatever. But it's going to give an initial ingress, egress, and with the additional resources you have in investment, you can run compute workloads. And we also said we're not going to dictate that you have to use vSAN, although we would love for you to use vSAN, become I think one of the 7,000 customers running it. You can use existing storage, because we realize that a lot of customers have investments in existing storage arrays, whether it's block or file, block or file based. The NFS, cool, right? We support it. It's on the HCL, we'll use it. And you want to use SDOE, if you want to use SDOE, feel free. If you want to use fiber channel, right, very prevalent, or iSCSI, you can use that for the initial edge and compute pod. Although, we do encourage you to look at using vSAN. Now, once you kind of grow out of that first initial shared edge and compute pod, which would start at a minimum of 4 nodes as well and grow from there, and we'll show you the rack layout in a moment. At some point, you may say, I need additional compute pods, right? And that's where you see over here this additional compute pods. And then again, this can be any storage, right? You start with maybe 4 nodes, you expand out. But the point is, at some point, you may need to add additional compute pods for additional resources. Maybe you want to say, I want to be able to deploy a compute pod for, an Oracle, right, or SQL, or maybe you want to have specific pods for, test development, or maybe Windows versus Linux, whatever your reasons may be. You can now have these additional compute pods, but that initial shared edge and compute pod is going to be the ingress and egress for your data center. And you can kind of see it represented here with the concept of the distributed logical routing. So as you'll see here, we'll talk about more in detail later. You'll see that in the management pod, we are actually using NSX. We use it quite extensively in the management pod itself. So the workloads running inside the management pod, many of those workloads like the vRealize suite, right? vRealize Automation, vRealize Business for Cloud, vROps, Log Insight, they actually sit on top of NSX logical switches or virtual wires, and they get their upstream access through NSX edges that are actually peered to those leaf switches, which are peered out to the border gateways and such. We'll talk more about that later. I'll use universal distributed logical routers. But you'll see here between the initial shared edge and compute and the additional edge and compute pods, we also have the concept of the NSX edges, right? Then workloads here will all sit on logical switches that are attached to a universal distributed logical router, that then have access to our edge and can go outbound to your WAN, your LAN, the internet, whatever you defined, using the power of NSX. That's just a quick overview of what the pods look like.
Before we move on, Ryan, I'm going to ask you a question that you've been asked before, just because somebody is bound to ask it. Sure. So, Brian, tell me, why are we using, when we're sharing the edge with one of our pods, why not shared edge and management? Why are we sharing edge with the compute pod?
That is a fantastic question. I get that all the time and I typically get that question because someone has just read the NSX design guide, right? Or they've taken a lab and they see management and edge together. I'll give you a couple of reasons that I particularly see. One is a technical reason, and one is more of to me, a security reason, right? I think they're kind of both connected. So if you look here at this management pod, right, this management pod right here, just imagine those 4 nodes here, if I can kind of circle them. These 4 nodes in management pod are vSphere clusters themselves. The vCenter that's managing it, right, is located in that cluster, right? So it's kind of self-contained in its own vCenter server and PSCs, right? Which just, of course, means it's going to have this NSX manager is going to be located inside there. The other piece is that for all the additional compute pods, we have here the shared edge compute and the additional compute. we actually instantiate a separate vCenter, for our compute pods and our shared edge. It basically means that we're going to have this separation. There will be an NSX manager for the compute. There will be a vCenter server for the compute. So the outbound, the ingress egress for all those workloads has to go through an initial shared edge compute pod. They can't be connected to those in the management pod. The other piece is, I say, it's kind of a, I like to see the delineation of security, right, and separation of roles. Like, this is management, right, and I want to keep my management, all kind of in its own stack and managed as one unit, and then manage the workloads for the business, right, as one unit, and limit the access of those compute workloads to the same fabric or same systems that are actually managing it. Nick, I don't know if you have add any more additional detail to that.
Yep, what it basically comes down to is you can't. The technical reasons don't let you, but from a security perspective, I agree with you. I think what we need to make people aware of is we are using NSX for management extensively. And you've already said that, but I'm going to kind of emphasize it just so that people understand that we don't necessarily want to share a universal compute transport zone across every single host, because once, from a security perspective, that's a big no-no, right? However, because we can't pair an NSX manager with management and edge, but have edge only talk to compute. It just doesn't work. So the only technical way to do it is to share it with compute, which makes sense because they're the VMs that need ingress and egress anyway.
Exactly, because there's a one-to-one relationship between the vCenter and NSX manager, and because separation and technical feasibility, that's why you see it separated, and it works out, in my opinion, fantastic having that separation, and architecturally it makes it easier because also when you want to hit some other bounds, maybe this is actually one of the pieces I have seen with customers is maybe you say, you know what, I've got PCI, non-PCI. Well, I want to make sure I actually do a separation. And I realize, there's a other kind of argument there about, how you can separate PCI, non-PCI, right? Or you have development and development, non-development. I know many customers that want to have that separation. Well, you could essentially set up different compute, pods, right, and compute vCenters specifically for those type of operations, and that's where you have that. I can have that separation.
I was actually going to ask this before, but you guys addressed it. That if you had a vCenter dedicated to management and a vCenter for the workload, and I think you just explained it. Thank you.
it makes it, yeah. Now we have diagrams on it. It just makes it really simple to manage. If you were look at our racks, right, they're pretty standard kind of guidance on the racks, right? You'll see dual power supplies are feed, so we can have redundant power, obviously. Our servers, right, you want to make sure they meet the requirements. So I mentioned, for the management pods, we use vSAN ready nodes because they're certified configurations. But for other workloads, right, and edge and compute pods, you can use anything that's on, is on the VCG, the VMware Compatibility Guide. You will see in our design, our requirements right now, or you'll have, we have a leaf and spine, layer 2 leaf and spine. You will see at a minimum you have 248 10 gig switches top of the rack. Those are top of rack switches. Each of the hosts are going to be plumbed into each of the switches. You'll have a 48 gig port with 1 gig connectivity, and that'll be used for out-of-band management. So if you're using, HP, your ILOs, right, you'd be plugged in those. If you're using Dell, right, I think it's still called iDRAC, you'd be plugging those guys in. I think at RSA is still IBM, what have you. And that's going to be for your out-of-band management for the IPMI connectivity to whatever that product may be, your interface may be for that protocol. And then, of course, we'll have spine switches, right? So we'll have at least two 40 gig spine switches that we're using for interconnects for our layer 3 leaf and spine connectivity, right? And that basically can connect our pods together. servers I mentioned, right? We do kind of open it up in different directions. You know, you do want to make sure you pick the right form factor. We are seeing typically customers will boot from SD, right? I rarely see customers booting off disk today. It's usually SD or SATA, and we provide guidance around those. And most of the times we will see us say, boot from SD. Not so much USB. Some customers still do that. It could be any combination of storage as far as for the compute pods and initial shared edge. But when you're talking about vSAN, right, that's where you start discussing things like, okay, well, what do I need for, hybrid or all flash, right? SD, PCIe, SAS or SATA, NVMe. Right combination of CPU, memory, and make sure you have the right network connectivity. And I have some more build out here. So for the management pod, let me just kind of build this out. This is kind of a typical load you would see for a management, the management pod, a host in a management pod, right? The form factor would be vSAN ready node, right? So it's all been typically rack mount. It's a certified configuration and a certified recipe from the vendor, right? It's on the compatibility guide for vSAN. It's got the right drivers. It's got the right BIOS. It's got the right build. It's got the right control firmware and controllers and everything to meet the recipe specifically for vSAN. All right. I can't stress that enough. And you will see those typically going to boot from it says the SD USB, SD, and or SATA DOM. Right. I see more and more SATA DOM today. Actually, especially see that in Cloud Foundation. And you will see us enable remote syslog to vRealize log insight. In terms of storage, for vSAN for the management pod, we do use one disk group. All we need in order to accommodate the primary storage we need for the entire management stack is one SSD for a cache tier. That's a 200 gigabyte SSD drive, and then a minimum of 2 1 terabyte SAS drives. And that'll give us enough storage across the aggregate of four servers to run all the primary storage and run all the VMs for the management stack. And I say that because we are doing very highly distributed deployments of the management stack, right? So if you think about vRealize automation, I think vRealize automation might be 10 or 12 virtual machines in the distributed form factor. We have 5 per region, 6 per region right now, at a minimum for vRealize operations. So it provides us enough, capacity and memory, CPU, and storage to run this entire management stack. 2 sockets, you can use Intel or AMD if they're still around. Set the high performance in the BIOS, and a minimum of 128 gigs of memory per host today. It may increase in the future. And then 2 10 gig uplinks for the top of rack switches. We do enable jumbo frames on the switch as well as the distributed switch and the VM kernel ports, and your 1 gig connectivity for your IPMI or BMC controller for the out-of-bound management. Now, in terms of initial shared edge and compute pods or compute-only pods, they're pretty much the same, right? But it can be anything on the compatibility guide. If you want to use vSAN ready nodes, you want to use blades, it can be either. You want to boot from SD, USB, SATA DOM, what have you. As long as it's on HDL, we're happy. You can use vSAN, right, in a hybrid or all flash. You could use or any other supported storage. Like I said earlier, you want to use NFS, you want to use fiber channel, right? Any of those, you can do it. And of course, CPU and memory, it's going to be up, really up to you, right? Most folks I see start at least 128 gigs of RAM at a minimum. But you're really going to want to size these edge and compute pods specifically for your workloads. We're not prescriptive on the compute pods. We'll give you some kind of guidance how to set them up. But we're not prescriptive because our customers and partners are going to be the ones who understand the application workload best themselves, right? What are the requirements for those workloads? And of course, we can, VMware can help you size those appropriately, but we're not going to dictate how you lay out and what hardware you pick specifically for your compute pods, right? That make sense? For some reason, my Alexa just decided to go off.
Lots of virtual nodding. Yes, that makes sense, Ryan.
Yeah. In your head. All right, cool.
I do have a couple of questions there.
Go ahead, Aaron.
Any reason that the management pod doesn't support all flash for vSAN? I'm guessing not.
So we're not saying it doesn't support. You can absolutely use all flash. We're just saying that at a bare minimum, right? You can use hybrid. This meets the requirements of the entire set. Now, if you want to eke out additional performance and you want to use all flash, I see no reason you can't do that. On our guidance, are we being prescriptive for a hybrid, Nick, or are we allowing all flash?
All right, let's talk about the prescriptive versus the non-prescriptive. Since we're here, what I'm about to say applies to every single thing that we prescribe within the VVD. The way we set up our design decisions is the way we test our design. So we haven't got hardware that has all flash in our test bed testing it. That's a choice that we've made up to this point. We wanted to have as low a barrier to entry as possible. All flash is a higher barrier, so we haven't gone there yet. That's the specific to all flash. You can use it, that's fine, but just be aware that we haven't tested it. So the benefit you get from the VVD is that we've done extensive interoperability testing. When it comes down to it, we do all the design work, we do all the extensive testing over and above what our normal product teams do. We say this is a tested solution. Right? It's not just hey, here's some software. This is an end-to-end solution that fits this use case at this scale with this amount of availability, and we will stand behind it because we have tested the living daylight out of it. Right? If you decide to deviate from our design because of a whim or a business requirement or a technical requirement, go right ahead. But the risk is on you as to whether you will see a potential problem in the future. Now, for this one, this is an example. I very much doubt you're going to see any issues, but there might be some obscure bug that you come across that we haven't tested yet. But then you're also safe in the knowledge that, well, the storage team at VMware tests vSAN all flash all the time. So that's tested anyway. So you might turn around and say, well, I don't want to use vSAN for storage on my management pod. Well, as Ryan said, we'd prefer you to. That's what we test with, and we know that it works really well. But we don't go out there and test with every single EMC array and every single NetApp filer and every single other storage vendor's product out there. We don't have the capability to do that. So what we do is we say, we've tested with this. We know this works. We know that it's that it will scale, that it's stable, that it meets our requirements. So one thing that we have is we have very specific technical we have design objectives that we have to meet. Effectively, they're our design requirements that we have to meet. So we wouldn't put in vSAN into our design if it did not meet our requirements. It does meet our requirements. It's cost effective. It provides the capabilities that we need. Therefore, that's what we use. That's what we test.
Yeah, I see it as, treat this as our required or our recommended minimum. If you can go better than this, you'll be fine. But you already tested that this should meet. When you're talking about having a management cluster with about every VMware solution, you can actually deploy hybrid and it will work. So that's basically what you're saying.
Exactly. But, if you went all flash, the price of flash is dropping, right? We get that. You go all flash, but if you deploy it, there may be a minor risk, right? If you say you enable deduplication and compression, we haven't tested that on the management stack. Maybe we will in the future, but we haven't done that just yet. So you could potentially.
And when Ryan says we haven't tested that, he means we, the VVD team, not we, VMware.
Yeah. Good point. Thank you. Let's talk about the network, right? Some of the basic concepts of the network. And sometimes we get some, people are like, what are you doing here? And they're a little surprised. But what we're doing in the VVD is we're actually using a layer 3 leaf and spine, right? You can think of this as kind of the cross network, kind of what's old is now new again, where at the top of the racks, right, we're going to have leaf switches, right? And each of these leaf switches are going to be connected to a series of spine switches, so that we have a really high-speed, highly redundant network for our basically, an IP transport backplane for NSX, because we are using NSX and we want a high-speed, high-throughput, and highly resilient network fabric for NSX. And so we are using a layer 3 leaf and spine. We do often have customers that say, whoa, this is a no-go. I'm using a traditional, 3-tier stack, and I can't do this. And this is kind of another one of those areas where this is what we're testing against. This is what we recommend. In fact, this is what our BU, our NSBU, our Network and Security Business Unit recommends for NSX. So we are using a layer 3 leaf and spine network in the VVD. Though we have had customers that say, I want to use traditional, and we have had some deviations from there. Again, because the high speed, you will see, 10 gig uplinks from the host to our top of rack leaf switches. So inside the rack, you'll see there's 2 top of rack leaf switches. Each host is going to have two 10 gig connections up, and from there, at the top of the leaf switches, they're going to have 4 40 gig connections up to our spine switches. If you look at it from what we call the cord pod, this actually needs a little bit of an update here, and I'll explain where it actually needs an update. But what you can see here is a representation of the pods, right? The management pod, right? There's 4 vSAN ready nodes, a shared edge and compute pod. It could be any 4 hosts, right? And additional compute pods. They're all connected up to the TORs in their specific rack, right? And those TORs are then connected up to the spine, right? 40 gigs from the TOR to the spine, and 10 gig from the 10 gigs from the host to the TORs. One thing that's really not represented here is that for the management stack and the initial shared edge, right, that are sitting in this rack on the right, they are going to have connectivity up beyond that spine out to your border gateways, right? So they can go inbound and out, have ingress, egress to your WAN, your LAN, the internet, or what have you, whatever your network infrastructure should be. But those on the far side, they're just solely for compute. Those should literally be just connected to your SDDC fabric, right? They're going to get their workloads that are running in those pods are going to transverse a transport zone and hit that edge pod, that initial shared edge and compute pod, so they can have those workloads can then traverse out the network and hit your border gateways for your LAN, WAN, etc. Does that make sense? This is not depicted in this diagram. I should actually have my border gateways here, but I don't have that defined. So what you'll actually see in the rack, we are using a layer 3 leaf and spine, but inside the rack, right, the representation of the rack here, just 1 leaf. But what you will see is that we are using a layer 3 top of rack, but what we're doing is we're presenting the layer 2 networks only within the rack. So those L2 networks, the span of those L2 networks are only within the rack, right? I'll show you a representation here in a moment, but that basically says, hey, I'm going to have, it's going to route out from my TOR to my spine, but in that TOR, I'm going to present the L2 networks that I need for things like management, vMotion, vSAN, replication. So use it for vSphere replication. I'll establish my VXLAN overlay on that using the L2 networks defined within the rack. And what that kind of looks like, kind of build it out here. We have some guidelines right? That will show you what we intend for customers to kind of look at. Customers typically use like a /24 subnet within the rack, right? Makes our subnets really simple. Typically use like .1 is your floating interface, 1.2 for the VRRP, and for your HSRP. But if you look here at this management network, right? This is our management, right? We're going to use a 1611. That's going to be the native VLAN. vMotion would be 1612, 1614 for VXLAN, for example. vSAN 1613. If you look over here, the example range, right? It's going to be a 16.11 /24, 1612, 1614. Kind of you see how it matches up. Now imagine this was only within one region, right? You can think of that 16 here as the region identifier. So if I was Los Angeles, that 172.16 could, I'm sorry, if I was San Francisco, for example, that 172.16, that 16 number would represent my region ID, right? And I would know that is specifically for San Francisco. If I change it to 17, I know it was for Los Angeles or what have you. That second octet is we kind of have guidance around that being for a region, and then that third octet is going to be more regarding the function, right? So hey, that maybe the vMotion network is going to be a 12, right? A 12 or 22 or what have you. So you kind of build those out. Same thing goes with the shared edge and compute pods, right? So it's really regarding like, let's make it as simple as possible, /24s. All these L2 networks are defined within the span of the rack, right? And create a numeric sequence that's really easy for you to identify the region as well as the functional role for those subnets.
Ryan, I think I saw that the default gateway that you had in the previous slide differed from what you were saying for the VRRP.
Oh, it's good point.
Okay.
This one actually happens to be from when I did this one. It was actually a lab that I had, but 253 sometimes is used. Great call out. We would recommend 1.1 here. Of course, I know a lot of customers that do use, and we actually see that internally ourselves, where we typically see a 253 used for the address to gateway.
That's perfectly fine.
So
just if anyone had a question.
One thing that I think is really good to point out, and you'll go into it on this slide, these are guidelines. These are not requirements. We're not stipulating that you have to have. That's why on this table it's got sample VLAN, sample IP range. We're not saying that you have to use the IP ranges that we're setting, because that may or may not be possible.
Yep.
But what we're doing is so that you can see a full picture, and so that we can actually deploy this and test it, you can see what we're using internally.
Yeah, and we represent this. You'll see what we're testing internally. You'll see it prevalent in our documentation. Your own organizational goals may apply, and you're going to have to overwrite these, but it gives you a starting point, right? And now you can start to look at where your organization is and where these guidelines are. Just map your implementation, accordingly that matches what your organization requires, right? Your organization uses a 253. Hey, thumbs up, right? All good. These are just guidelines, right? We're not going to just not set in stone here. In terms of the deployment topology, this is just a visual representation, so I don't recommend, I say this a lot of times, I don't recommend anyone rack and stack in this manner, because it may, some people may not appreciate you racking and stacking in this manner. But at the top of the rack, right, you will see, you have your TORs and your management switches. You may have your spine switches in there as well, or they may be at end of row, center of row, or what have you. Management pods, right, is represented here. You can expand that management pod if you want to. Management pods in blue start with the minimum of the four vSAN ready nodes. Your shared edge and compute seen down there in the green, minimum of four nodes to start with. Anything compatible, right, and you can grow from there. if you want to rack and stack like that, that's fine. Typically, I see most customers start at the bottom and then go up. If you have to, just make sure you have the stabilizers on your racks. follow your guidelines. Then to the right here, you'll see you can add additional compute pods, right? You probably will go beyond that first initial rack. You need to add additional compute pods. Now, today in the design, we make sure for those additional compute pods you do design for your workload requirements. We do, in the 3.0 release, require that a single compute cluster per rack. So the clusters today, if you define the cluster, say in that first additional compute pod, you would want the cluster to simply be within that rack. It wouldn't be vertical versus horizontal today. I'll underscore today. And of course, you want to make sure your nodes are homogeneous within the pod, meaning, hey, let's make sure we have all the same type of hardware defined so we can use those, especially if you're using like vSAN. And you can go here heterogeneous across racks if you want to, because your clusters aren't spanning horizontally across the racks. Again, that may change in the future. We talked about distributed management workload a little while ago. In terms of ESX, right? As mentioned, proper DNS NTP. We do synchronize our time with our NTP source. We do make sure to have good forward and reverse DNS long and short. Boot is typically going to be SD or SATA DOM. We do enable syslog. We have some guidance around how to enable remote access for the DCUI, exception users and lockdown mode, requirements around shell access, and of course, we talked about the network connectivity and the CPUs and such while ago. You do see we do add the host to Active Directory. We renamed the ESX admin to, I think it's called SDDC admins, and we provide the exception users. They'll have the ability to log into the shell and log into the DCUI. So we do make sure we have guidance around how to authenticate for those remote access components. So let's kind of build this out. So let's kind of look at what the clusters look like today at a base layer. And let me do a time check to see where we are. We should be able to get through this real quick before. So the management pod, right, starts with 4 ESX hosts. We do use vSAN, right, for these guys. We also use NFS. This NFS is primarily used for a place to store our backups, right? We provide some guidance around using it for backups. Also, for using it for templates and our content library that we use for vRealize automation. And we also use it as an export for vRealize Log Insight. As we will archive logs from Log Insight, we want a place to deploy it, and we use an NFS export as a location for logs that are rolling off of Log Insight. Those hosts are all going to have their own distributed switch, right, within that cluster. There'll be 2 VTEPs, and it's route based on source ID is why the load-based teaming is set up. And there will be a universal management transport zone deployed in hybrid mode. And so we're not using unicast, we're not using multicast. We're using hybrid mode for the control plane operations. The initial shared edge and compute pod, right, it can be any 4 hosts using any supported storage that we mentioned earlier. Again, NFS is going to be used for backups. It's going to be used for templates. It's also going to be used, and those are what's used for primarily there. And each and every compute cluster, right, or compute cluster and pod is going to have its own distributed switch. So as I go from here and I build out and I add an additional compute pod, right? Again, I can use any supported storage, right? But each one is going to have their own distributed switch built. But across that top layer, I'm going to add those all to a universal transport zone. This gives me the ability to deploy a universal distributed logical router, link logical switches to that UDLR, and then that UDLR can connect up to an edge devices that are deployed in my initial shared edge compute pod. It basically means my workloads can move throughout the shared edge compute pod to an additional compute pod 1, 2, 3, or what have you. but they can move about, whether you want to, vMotion from one cluster to another, but all those logical networks are all going to be available across all clusters if I so choose to do so. Gives me maximum workload portability. I talked about VLANs. Distributed switches, as we start to wrap up here and we'll get more in detail in the next one. Those vSphere distributed switches that you would see in each of those three cluster types, you'll see management, right? The VLANs that are provided within the rack from the L2, management, vSAN, VXLAN will be auto-created, replication. You'll see in the management, but you also see these two uplink networks. These two uplink networks, as we'll talk about at another point in time, these are actually used in order for NSX edges, both in the management as well as the shared edge compute. In order for those edges we deploy to link up across the transit network and actually do BGP peering, so they can do route redistribution from our software-defined network up to the physical network. So any virtual networks we define inside the SDDC, whether it's in management or where compute workloads run, will then have their routes redistributed all the way up to my physical network, so we can get inside and outside. We can see those routes being redistributed. So that's what the uplinks are used for. They're used for our edges to be able to communicate with top of rack switches and establish that peer relationship, so we can start to exchange routes. And then for additional compute pods, it's very basic, right? We just need management, vMotion, and vSAN if you're using it. You will notice, though, that we are using jumbo frames. It's 9,000 on the switches, obviously, 9,000 on the VDSs and the specific port groups. Pretty much all of them but management are using 9,000 for the MTU in the design. And so with that, just a quick note on teaming policies, right? We often get asked, we are using a route based on physical NIC load for pretty much across the board, across the NICs, except for the VXLAN, where we're allowing that to be auto-generated by NSX for VTAPs, and that the teaming policy is, because we're letting VXLAN do it so we can have two VTAPs, it's going to use route based on source ID for the teaming policy for NSX. I'm going to wrap it up with this, Ariel, because I know we're at the top of the end of our time here. In terms of storage, the next time we'll dive into the virtualization piece. In terms of storage, we have I mentioned the types of storage. Primary storage is going to be virtual SAN, and that's in our management pods. You can use, again, any supported storage, HCL support storage for shared edge, compute, and compute on only pods. The only place we're trying to provide guidance, right, is around the management pod and using vSAN. If you want to see something different, this is what we've tested, right? For example, management pod, vSAN, hybrid, right? And that secondary storage, again, NFS is used for our backups, to provide guidance for backups, for our log archives from log insight as we roll off logs, and we want to keep them for a retention period. And we roll those off to an NFS export, and then for content library and templates that are used for and consumed by vRealize automation. And look for something like this. I'm going to stop here, take any questions as we wrap up, and I think in the next session we can dig into the virtual layers, as we'll call it, the virtual tiers, a little more.
We're going to have to go super fast. There's still a lot to go.
No worries.
Still a lot to go.
No worries at all. Let me go ahead and open the microphones in case anybody wants to ask any questions. And one thing that we have to all realize is that any one of these topics could be 20 minutes. So try to keep the questions as easy or as targeted as you can. I'm guessing that you get a lot of questions about the options that you guys choose on, and it's all the edge cases that people are always bringing up to you.
Yeah, that's right. I mean, when we first started out, one of the things that we did was we had to make sure that we weren't trying to be all things to all people. We had a very strict set, as I said, a very strict set of design objectives, and we designed to those objectives. Now, there's always going to be edge cases no matter what you do, but if we try to be all things to all people, we're actually going to be nothing to everyone, is what it comes down to. So this is hopefully enough for most people out there. And if there's edge cases, maybe you can use the VBD as a starting point, and then deviate where you do have those different requirements.
Yeah. The only last question that I got was, when you have your compute pods, do you reuse the IP address scheme, since those are basically contained within them? So the literary question, sorry, it was, if each rack is an L3 boundary, why not reuse the VLANs? So VLANs, not IP scheme. Sorry about that, Graham.
Oh yeah. So basically, like reusing, say I could have VLAN 1611 in rack 1, but since the boundary of the L2 was in that rack, I use 1611 in rack 1 and rack 2 because it's the boundary. I believe we are. I don't know what we've tested against. Are we doing separate VLANs or not? I'd have to get back and see, but I believe because we're keeping it the same, we can use the same VLANs across racks. And I believe we are. I can verify that and answer that. I just talked to Mike and verify it. But I believe we're using the same VLANs across the racks.
Okay.
Just different IP schemes.
Awesome.
But I believe we are. I do want to call your attention real quick to the community, right, and some documents that we do have. There's a VBD community, and one of the things, we have all kinds of cool things, and I'll show a couple of these. And one I want to call your attention to is this design decision checklist. So if I bring this up, my Excel's thinking about opening. Inside this document are over 230 design decisions that we have in the VBD for this release. You can walk through them, right? You'll see, here's my physical, right? Here's my design decision, my justification, implication. What does it affect? What section is it for? What subsection? And you can start to look through these, and like I said, you can read them like the 1980 stereo manual, but you start looking at, do you agree with this design decision, or do you not agree? And start to kind of codify specifically which decisions you agree with and don't agree with, and see where your deviations may be in the design. This is a great resource to start looking at what and how we defined the product or the solution.
That's perfect.
In actual fact, when we're talking with our partners, that design decision checklist is the very first thing that we go through. What we do is, most people have a design in mind, right? We go in there and they say, yeah, well, we've got this design, we've heard about this VBD thing, but we like our design better. Right. Okay. No. Well, that's valid as well. Valid for you, but it hasn't been validated for potentially the scale or the availability. Let's go through the design decision checklist, and let's just cover off where you do or don't match with our design, and then where all the ones that you do, great. Let's just assume you're going to do that then, and all the ones that you don't, let's go through and have a conversation and say, well, why do you need to do it differently? Because I think ultimately it's not a hard thing to grasp the fact that this has been tested way more than any customer could ever do off their own bat prior to releasing a system into production, right? There's no real question about that. But what it comes down to is, well, there are specific ways in which some architects or system integrators like to do things, and it's about, well, why do you need to do it that way? Why can't you do it the way that the VBD prescribes, since it has been validated and tested? And this facilitates that conversation and steers the conversation in a way to say, let's just concentrate the conversation on just these few things that may not align to the VBD, and then we can have a talk about it, and we can explain through our justifications and our implications as to why we've designed it this way, and some things that you may not have thought about.
No, and it also, if for some reason you start hearing a lot of backlash on a decision, that gives you an opportunity to evaluate if you took, nobody's perfect. So maybe at some
Yep.
point you say, this could be an improvement. So it's
Yep.
great.
And
Absolutely.
we have seen that. We have absolutely seen that, and we have taken that feedback back, and put those into upcoming things. I would like to say that when I've talked about these design decisions, start talking to customers, start saying, listen, with 230 design decisions, they've got their idea of what design should look like. They're ready to kind of go head to head and have that conversation, which is great, right? Makes it very lively. We'll get into 20 decisions in. They'll be like, yeah, that makes sense. That makes sense. You start hitting the 50 mark, right? The 100, and they're like, okay, I agree with these. Or you might find one or two that they just don't agree with, and finally they're going, okay, I give up. You guys have obviously thought about this, right? And we've worn them down by that time because we've thought about all these in great detail, because there's a lot of justification and there's a lot we identify in the application that may be affected. We put an awful lot of thought into each and every one of the design decisions, and when customers go through all of these in a setting where it's the first thing we do, like Nick said, they get an understanding of, you really have spent a lot of quality time documenting these, and it makes sense because we defined what we wanted to build, right, with design objectives, and then we created design decisions to meet those design objectives, right? And we find only very few things that people may or may not agree with.
And I love it, especially for people studying design. This is a great resource as well.
The last piece I'll leave you with is I don't know how people have seen this, but we actually released this kind of as a community release. But look at the VBD here, and this is based off the 3.x release. vSphere, NSX, VDP, SRM. These are all the ports and protocols, right?
Nice.
So what port did it use? What protocol was the source and the target and the purpose? Right? All identified and how they're used in the VBD. Probably, I would dare say, probably the most complete list of all the ports and protocols you would see when in a VMware software-defined data center today.
Yeah, because the KBs are all over the place. So yeah, this one place.
KB documentation. Big shout out to Gary Blake, one of the architects on the team on Nick's team. Has put a lot of effort here. I'm sure Nick himself. Very great resource that folks can use. And so just kind of just showing the design decisions, the ports, the protocols, all this amount of effort that you would have to research yourself and the time it would take to do this. We've done a lot of this work for you already, right? And we've tested it, and we continue to test it on a daily basis and take your input, right? And I'll leave it with saying, reach out to me, Nick, Gary, and others, Blair, William Lamb, et cetera, all on the team. If you have questions, go to the community, post a question. If you have an idea, right, or you disagree with something, right, the best way to get feedback is go here in the community and post something, right? We'll be happy. You get direct access to Forbes Guthrie, is also here. He's the PM, as well as others. Direct feedback, right? You agree with something, you love something, you hate something, say something, right? And it's by doing that we will make this better, and you have a direct opportunity to help even shape some of that direction.
It's awesome. Nick, you were going to say something?
I was just going to say one of the things that is coming in the upcoming release that I will drop a little bit of a tease here. It's not on the early access because the architect just finished it the other day. I polished up the diagram for him yesterday, I think it was, and that is, you saw that spreadsheet with all of the. You're going to tell me that you've got it there now, Ryan? You're looking for it now?
It depends on what it is.
The service account stuff.
But I could bring that up. It's incredible.
So we've got this idea that we want service accounts for everything, right? Rather than just using the default administrator account. So in the 4.0 release, we're going to have a diagram which depicts the logical representation of the entire SDDC and then the service accounts that are used for the communication between each and every component.
That's amazing.
So not only do we have all of the ports for the communication listed in tabular format, which is what you just saw before, we've also got a logical representation of all of the components with all the service accounts that we have configured. So for those of you that are security minded, that may help quell your fears.
It's amazing the amount of work that you guys have done with this and are still doing. So we really appreciate it. All right. Well, I don't have. I mean, apart from oohs and ahs, people saying, "Oh man, that's really useful." I don't have any more questions. So if you guys agree, we'll stop right now. Thank you so much for the second delivery. We're looking forward for the third one. Thanks again.